Well, hello, this is Mrs. Sharp, and this is a video for Learning Target 3.3 Part 1. And this is going over knowing what's known as the atomic number of an atom, what it represents, and how you can find it. It's also going to talk about defining isotopes and explaining how an isotope's mass number is related to its mass number, I guess, but it should be its mass. You're also going to define an ion and explain how an ion's charge is determined, but that's going to be in part 2. So this video, we're going to start with the atomic number and what it represents. First of all, atoms are arranged on the periodic table according to their atomic number. So we start with 1, and it goes in order from 1 all the way to 118. That's what we use as our basis of organization on the periodic table. So the atomic number is this: the number of protons in one atom of a certain element. This is kind of the atom's fingerprint. This is unique for each and every atom. So if you look at atom number, let's say, I'm quizzing myself, number 20. Atom number 20 is calcium, and calcium has 20 protons in its nucleus. That is its fingerprint. If it has any other number besides 20 protons, it cannot be calcium. Because all atoms are electrically neutral, that means that their charge overall is 0. The number of protons must be equal to the number of electrons. Therefore, if calcium, Ca, has 20 protons, it must also have 20 electrons, because if you have a plus 20 and a negative 20, overall, that is a charge of 0. So the atomic number in an atom, which is neutral, is also the number of electrons. The symbol for atomic number is the letter Z. So if you see something like Z equals 15, you know that it's talking about the element on the periodic table with 15 protons in its nucleus. In this case, that would be phosphorus. So let's move on to isotopes and how it relates to the mass number. This should be review. All atoms of the same element have the same number of protons and electrons, but the numbers of neutrons can change. So an isotope is an atom of the same element, but with a differing number of neutrons. Neutrons change the mass of an atom. Therefore, isotopes of the same element have what we call different mass numbers. The only thing different about these atoms are their masses. Many known isotopes are artificially made, so they are radioactive. We're going to talk more about that later. So these are atoms of the same element, but with a different number of neutrons, and that's going to give us a different mass number, which we need to define. And that's because one neutron is exactly equal to 1 AMU, so every time you add on a neutron, you're going to add 1 AMU to the mass. So here's where we're going to define mass number. The mass number is the sum of the protons and the neutrons in the nucleus, and that can be represented by the letter A. So we have atomic number is Z. A is equal to the protons and the neutrons. So therefore, if you had calcium again with our 20 protons, if you had 20 neutrons, your mass number would be 40. So that isotope would be known as calcium 40. So that right there is your mass number. So that's the total number of nucleons. Remember, protons and neutrons are known as nucleons because they live in the nucleus. That mass number would be 40. This is some ways that we can write. So this is a way we can designate isotopes. The first is what I just showed you by its name, hyphen, mass number. So we have carbon, And then the 12, which I've underlined for you, is the mass number. So that's protons and neutrons. So that means for this carbon 12, if I look up carbon on the periodic table, it has 6 protons. So this isotope must have 6 neutrons. And this is the most common form of carbon because it's the most stable. And atoms like to be stable. So that's one way you can write it, is by the name dash mass number. You can also do it through symbols. So the symbol for carbon is C. Its mass number appears, and its atomic number appears. Notice that the atomic number does not appear in the name designation. So that part is missing, but that means you can just find it on the periodic table. So you've got the mass number, and it doesn't have to be on the top. Sometimes it's on the bottom. And then you also have the atomic number, which is the protons alone. So this is the same isotope of carbon. Remember that since these are atoms, this is also going to give us the number of electrons in that atom. So the mass number is the atomic number plus the number of neutrons, because the atomic number are your protons. If you want to find the number of neutrons, that means you can just take your mass number and subtract your atomic number. Here we have a chart of the 3 different isotopes of hydrogen. So one thing I want you to notice here is that everything stays the same in these atoms except for the neutrons. So hydrogen 1, hydrogen 2, and hydrogen 3 all have the same number of protons because that's what makes it hydrogen. Hydrogen has 1 proton. Because they are all electrically neutral, they all have an equal number of electrons to protons. But they do have different mass numbers. So hydrogen 1 has a sum of protons and neutrons equal to 1. That means 1 proton plus 0 neutrons equals 1. 1 proton plus 1 neutron equals 2 for the mass number here. 1 proton plus 2 neutrons equals 3 here. So that's how we get hydrogen 1, hydrogen 2, and hydrogen 3, because there are 3 isotopes of hydrogen. The only thing that changes is the number of neutrons, which affects the mass number. So now we're going to practice. Oops. I thought we were. We're not going to talk about ions. We're going to practice. So I'm going to give you a few examples here, and I want you to try them. So let's start with, I want you to do protons, neutrons, and electrons. And I'm going to give you 5 examples, and then I want you to pause and check your answers with mine while I explain. So our first example is going to be chromium. And I want that to be chromium 52. And then I'm going to do and then finally, let's see, do okay. So pause, try to figure out the number of protons, neutrons, and electrons, and then when you're ready, unpause, and you can check your answers with what I have. Okay, for chromium, I see that the mass number is 52. That means protons and neutrons together equal 52. So I need to go to my periodic table and find out what chromium is on my periodic table in terms of its atomic number. And when I look at that, chromium's atomic number is 24. So I have to figure out how many neutrons based on the fact that 24 plus the number of neutrons equals 52. So if I add to that 28, that will give me 52 altogether. The number of electrons is always going to be equal to the number of protons, so that's 24. For potassium, the mass number is 40, and this time I'm given the atomic number, which is 19. And I can look on the periodic table to double check that. So that means I need to have 21 neutrons to make 40, and my electrons have to be equal to my number of protons. Lastly, I have nitrogen. Nitrogen, in this case, has a mass number of 15, which means its protons and its neutrons have to add up to 15. I look at the periodic table. Nitrogen has an atomic number of 7. That means it must have 8 neutrons. And because protons have to equal electrons, I have 7 electrons. Please notice that when you look at the mass of nitrogen on the periodic table, its mass is actually a lot closer to 14. This particular isotope happens to be nitrogen 15, but there's a reason that on the periodic table it says 14. But for now, we're being told that the mass number is 15. So it's important to recognize that when we're calculating our neutrons, remembering that that can change depending on the isotope. So that's it for now. Hope you enjoyed these notes, and I will talk to you later. See ya!